Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome you for the next lecture. In this lecture, we will study nodal analysis, mesh analysis, nodal and mesh analysis by inspection, capacitor, and inductor. Nodal analysis, it provides a general procedure for analyzing a circuit using node voltages as a circuit variable. So in nodal analysis, you must understand that the main variable is important thing. The main variable is node voltage. Okay, main variable is node voltage. Let's see. So what is the way steps to determine the node voltages? First, we select the reference node. Then we assign the voltages, V1, V2, Vn, n-1 remaining nodes. So we assign voltages on n-1 remaining nodes, and the voltages are referred with respect to the reference nodes. In nodal analysis, we apply KCL to all n-1 node, non-reference node. n-1 is non-reference node, only one is the reference node. So we apply Ohm's law expressions and we apply the KCL on n-1 non-reference nodes. Then we apply the simultaneous equation. Let's see the question. Example. This is, let's suppose we name it V1. This position we name it V2. Okay. So this is the node which is V1, and this is the node which is V2. So what do? We take, like we say that the entering I, we say that I entering equal to I leaving. So those who enter in the node, this node, equal to those who left from this node. You must have to define the direction of the current, is very important. So here we see that. So what are the node at, let's suppose we apply at node 1. So which are the nodes is coming inside the node 1. So we can say that, let's say this is I1, and we can say that this is I3, and this is I2. Okay, so in 5 ampere is entering, so 5 equal to, or you can say I1 equal to the I2 and I3, because these are two leaving. So we can say I1 equal to I2 plus I3. How to calculate I2? For calculation of I2, we can say that V1 minus V2 divided by the voltage. We can say that voltage drop across this resistance divided by the resistance is equal to the I2. So we can say that I2 is equals to voltage across 4 ohm divided by 4 ohm. So voltage across the 4 ohm is V1 minus V2 divided by 4. When we say that the V1 minus V2, this means that the current is leaving from V1 toward V2. So we have I2 is equals to V1 minus V2 upon 4. Here this is the reference node, as you know that this is the reference node. So V1 minus 0 divided by 2 ohm is equals to I3. So V1 minus 0 divided by 2 ohms equal to I3. So the equation becomes I1 is 5 ampere, I2 is V1 minus V2 over 4 ohms plus I3 is V1 minus 0 equal to this. So we have to solve this equation. Let's take an LCM first. We have 4 as LCM, so it becomes V1 minus V2 and plus 2 to the 4 becomes, so 2V1 equal to 5. So we can say 3v1 minus v2 equal to 20. So this is equation 1. So for v2 we can say that which are the entering nodes. This is entering node, this is entering node, this is leaving, and this is leaving from here. So we can say 5 is leaving, so 5 is leaving on the leaving side, 10 is entering, the 10 is on the left side, entering side. So this one we have to calculate, this is leaving, so we can say v2 minus 0 divided by 6 ohm on the leaving side. So we have v2 minus 0 divided by 6 ohm, so this is the leaving side and this is the entering side. So entering side is I2 is entering, so I2 is v1 minus v2 divided by 4 ohms. So v1 minus v2 divided by 4 ohms. So we can calculate this one, that we take an LCM and we have v1 minus v2 plus 40, because this bottom is 1, this is 1, so equal to 30 plus v2 divided by 6 is comes here, so we can have 6v1 minus 6v2 plus 240 equal to 4 multiplied here, so becomes 120 plus 4v2. So we can say that 6v1 minus 6v2 minus 4v2 equal to 120 minus 240. So we have 6v1 minus 10v2 is equals to minus 120. So we can say that if we divide by 2, so it becomes 3v1 minus 5v2 equal to minus 60, or either side if you take a minus common here, so we can have this equation. If you take minus common here, so it becomes minus 3v1 and plus v5v2 equal to 60. So we have equation 2. So because currently here we have two unknown variables, for n unknown variables we required n number of equations, at least n number of equations. So currently we have two unknown variables, which is v1 and v2. So we must have at least two equations, which is this one, this is equation 2. So we have two equations. Once we have two equations, we can do simultaneously, we can do many techniques we can use. So you can use substitution method, whatever technique you want you can use it. So here we are trying to use using a Cramer's rule. So Cramer's rule say we have first we have a matrix of coefficients. So we have a coefficient of 3 minus 1. So we have a coefficient of 3 minus 1. The second coefficient is minus 3 5 minus 3 5, and we have v1 and v2 equal to the right side. We have the right side is the constant is 20 and his constant is 60, so we have constant here 20 and 60. So this is the equation, right? A1 x plus b is b1 is equals to c1, a2 x plus b2 equal to c2. So we make a matrix a1 b1 a2 b2. Here we have x and y, so we have y here is equals to c1 c2. So this is the way we can write it, the equation. Now Cramer's rule say first we have to take a determinant of this matrix. So we have this is delta. We say the determinant of this matrix. Let's suppose we can say matrix A. So delta is the determinant of A. Then Cramer's rule say that we replace the first column with the right hand side constants. So we replace this one. So this new matrix becomes delta 1, and the matrix becomes A1, and the mod of A1 is the determinant of A1 is delta 1. Similarly, when we replace C with column 2, so we have A2, and the delta 2 is equals to determinant of A2. So when we say the value of x, to find the value of x, we can say that it should be delta 1 divided by delta. So similarly here we have, this is V1, so we can say first we have to take a determinant of this, which is delta. So we have to take a determinant, and you know that for determinants, this multiply by this, minus this multiply by this, 3 5 is 15, minus, and minus minus plus, 3 1 is 3, so it becomes 3. So 15 minus 3 is 12, so determinant of 12. Then we have to replace, for A1 we have to replace with this column. So we could replace this column, as you can see here. So the determinant of this one is 5, 25 to 20 is 25 is the 100, and minus, and minus minus plus, because minus is the formula, and minus 60 is the answer. So minus minus plus is 100 plus 60, because like this now, 20 into 5 minus minus 1 into 60. So we can have 100 plus 60, and to calculate the V1 we must divide by delta. So the delta is 12, so we divide by 12. So the answer is 13.33 volts. To calculate the Y, so we have to divide by delta 2 divided by delta. So how to calculate delta 2? We have to replace second column to make A2, and then we have 3 into 60 minus minus 3 into 20. So minus minus become plus, 60 and 3 8 180. So 180 raised to 40 divided by 12, it becomes 20 volts. So this is the first example, that once we have V1 and V2, so we can calculate now the currents. We can also calculate the current here. However, we don't ask for the current, but we can also calculate the current. So to calculate the current across I3 is equal to V1 divided by 2. So what is V1? V1 is 12.33 divided by 2. This becomes 6.66. Okay. So similarly, we have I1, as you know that I1 is 5 ampere, is a constant because this is a source, and we have to calculate I2, and I2 we have to calculate V1 minus V2 divided by 4. So we have V1 minus V2, and what is V1? V1 is 13.33 minus V2 divided by 4. The current is negative, minus 1.6 ampere, telling that the direction we have supposed is not correct. The current is flowing from V2 to V1. So here another we have remaining. We have I1, I2, I3, and this is I5. For I5, I4 is constant. This is I4. So we have I5 is yes, you can say that I5, to calculate I5, V2 divided by 6. So we have I5 V2 divided by 6. For I4 is 10 ampere. The next example, again we have to do the same thing, but the only thing that in this questions we use the dependent source. The last time we have all dependent sources. So what we have to do? This ones, how many? First we have to tell the reference node. This is the reference node. Then what is the task? Then we have to select the voltage nodes. So we have V1, and then we have V2, then we have V3. So this is the things. So we have to calculate the current, as we already have the direction here. This is the one node, this is second node, this is third node. So the direction 3 ampere is entering, and I1 and Ix is leaving. I1 and Ix is leaving. So entering equal to the leaving side. So we can say that 3 is equals to I1 plus Ix. Okay. So what is I1? Let's say calculate I1. I1 is direction from moving away from the V1. So V1 minus V3 divide by 4 ohm is I1. So V1 minus V3 divided by 4 ohms. So for Ix, so it's moving away from the V1. So it means V1 minus V2 divided by 2 ohms. So we have V1 minus V2 divided by 2 ohms. Similarly, we have to do apply for uh, node 2 and for node 3. As you can see, for node 2, this one is entering inside it, so entering side. So this is entering one, this is Ix is enter, and I2 and I3 is leaving. So this is I2 and I3 is leaving. So entering is equal to the leaving side. You can have entering equal to the leaving side. As you know, the Ix equal to V1 minus V2 over 2 equal to I3 is V2 over 4 ohms, and I2 is because current is leaving from V2, so it's V2 minus V3 divided by 8. Okay. Similarly, we have I1 plus I2 equal to 2x. How is this one? You can say that this one is V3, because V3 in V3 the I2 is enter, I1 is entering, this 2 is entering, and 2x is leaving. So leaving equal to the entering equal to the leaving side. So I1 plus I2 is equals to 2ix. I1 plus I2 is equal to 2ix. So we have I1 and I2. We do know that what is I1. We do know that what is I1. I1 is V3 minus V1 minus V3 divided by 4, and the next we have I2. I2 is V2 minus V3 divided by 8, and we have 2ix. So 2 into Ix is where is Ix? Ix is this one. So which is Ix? This means that V1 minus V2 divided by 2 ohms is Ix. So we can say, we can see that V1 minus V3 divided by 4 plus V2 minus V3 divided by 8 equal to 2 V1 minus V2 divided by 2. So we have, because we have in this questions we have 3 variables, 1, 2 and 3 variables. So we have 3 unknown. So we also requires 3 equations. So the equation 1 is this one, equation 2 is this one, and equation 3, once we solve it, will become equation 3. And equations for equation 3, we can if we solve it, let's say the LCM is 8. So 2v1 minus 2v3 plus v2 minus v3 equal to, we have 2 to 2 cancel, so we have v1 minus v2. So we can say 2v1 minus 2v3 plus v2 minus v3 is equals to 8v1 minus 8v2. So we can say that 8v1 minus 2v1 minus 8v2 minus v2, this is 3v3 is plus 3v3 equal to 0. So we can say that 6v1 and 9v2 minus, so we have 6v1 minus 9v2 plus 3v3 equal to 0. So we can take out 3 commons, so 2v1 minus 3v2 plus v3 equal to 0. So this is equation 3. So we have 2 minus v3 plus 1 equal to v3. So this is the equation we have. So now we have the same, use the primal rules, whatever the rules you want, substitution, equation, so whatever the technique you want to use, you can use to solve the simultaneous equation. But in this course I'm using the Cramer's rule. So first we have to calculate the determinant of this one. So the determinant of this one, so we can calculate. We have If we see, this is 3, and then 7, 1, minus 1, minus 3, then minus 2, then we have to calculate this one. This becomes minus 4, 1, minus 1, 2. So we can say that like this. What I say, 3, 7, minus 1, minus 3, 1, minus 2, minus 4, minus 1, 2, 1, then plus minus 1, minus 4, 7, 2, minus 3. So we have 3, 7, 7 into 7, minus us, minus plus, and also minus is there, so it becomes 3 minus 3, minus plus 2, minus 4, minus plus 2, then we have minus 1 plus 12 minus 14, then we can say 3, 4 plus 2 into minus 2 minus 1 into minus 2, so we can have 12 minus 4 plus 2, then we have equal to 10. So this is the determinant of delta. Similarly, if you want to calculate the determinant of the next determinant, if you want to calculate delta 1, so what we have to do, we have to replace this one with this one. So as we replace it, so we can say that only the 12, 7 minus 1, 3 minus 3, 1, because the remaining are 0, so no need to calculate the next parts. So we can have 12 into 7 minus plus minus 3 becomes 12 into 4, which is 48 delta 1. So delta 1 is 48. Similarly, we can calculate delta 2 and we can calculate delta 3. I also wanted to show you another technique, that how to calculate the determinant. So maybe few of the students know about it, maybe few of the students do not know about it. So currently, when you have matrix, so we have 3 minus 2 minus 1 minus 4 7 minus 1, then we have 2 minus 3 and 1. This is the delta. Actually we have to calculate the delta, this one. What is the way? You extend this. If I just make a line so you can understand, I repeat the row 1 and row 2 again. 3 minus 2 minus 1, then we have minus 4 7 minus 1. So way we have to use, this is the way. Let's change the color, so we can say that we use this, multiply this line, we multiply this one, we multiply this one, we just multiply with plus, and we multiply this is 3, we multiply this 3, and we multiply this 3. So here what is the say? We can say this one like this: 3 into 7 into 1 with a plus sign, plus minus 4 into minus 3 into minus 1 with a plus sign again. Then we have 2 into minus 2 into minus 1. So we have this one, and then we can say that the next one, I say these are the lines which are minus. So we say the symbol is minus, like minus 1 7 2. Then we have again minus, then we have minus 1 into minus 3 into 3. then we have again minus, then we have 1 into minus 2 into minus 4. So we can say that, so we have the first one is equal, the first one is 21, the next one minus minus plus, it becomes plus 12, minus 1 it becomes minus 12, then we have 4, then we have minus itself, so minus 7 14, minus minus plus it becomes plus 14, then we have minus 9, then we have minus 8. When we sum up these things, it also becomes 10. So there are two different techniques, but whatever the techniques you want to use to calculate determine is your choice, and not forcing any student to use a specific technique. I'm just giving the tool to calculate how to calculate this one. Make sure this is the technique that you use to calculate only 3 by 3. I'm telling you, is a way to calculate only 3 by 3. Please do not try to use this technique for 4 by 4. Okay, basically the rows, number of rows we have to put it is the factorial. Currently we have factorials of columns, that if we have a 4 by 4 matrix, so we have a factorial of 4. If we have a 3 matrix, 3 by 3 matrix, so it becomes a factorial of 3. So the factorial of 3 is 3 into 2 into 1, so it becomes 6. So whatever the number of rows I want is just a number of rows, that factorial minus 1. So this is the number of rows I want. For 4 factorial, I have to calculate this one, so this becomes very large. It becomes 24 minus